Start us off, let's have a look at sulfuric acid. Now, sulfuric acid, okay, we need to write out as H2SO4. Now, where are you getting that one from? That is coming from page 26 at the top where we gave you all of your acids. And when we look at sulfuric acid, so I'm looking again at this one right up the top here, what is the negative part, the negative ion from sulfuric acid? It is sulfate, and sulfate is SO4. Question? Yes, my advice is, but we're going to practice it now. They can be. No. So, yeah, so we'll talk about it in a second, but they just come from your ions list, okay? Now, when we're talking, our next part is magnesium metal. And what is the symbol for magnesium metal, anyone? Mg. And we just write it as capital M, little g. Now, here's the trick. We take the metal, and we take the symbol for the metal, and we write that first for our salt. So it's going to be Mg. We then take the negative ion from our acid. And what was the negative ion in our acid again? Sulfate. So I'm just going to highlight the SO4 component here, sulfate, and we write that as MgSO4. Now, if I was to think, and I don't need you to write this, but I'm going to pop it up on the board to make it really clear, magnesium has a charge of +2 and sulfate has a charge of -2. So how many do I need of magnesium and how many do I need of sulfate to make them balanced? 1, okay? So right now, are they balanced in that ionic formulae? Great. The final thing that we get as a consequence of this reaction is hydrogen gas. It never changes, so H2. Now what I'm going to do, and I apologize that I've done it a little bit backwards here, is now I'm going to write the names for these things. So if we look at this salt, the thing that is made up of the metal and the negative part of the acid, its name is magnesium what? Sulfate. Great, so we're going to write magnesium sulfate plus hydrogen gas. But we have one final step here, everyone. What is our final step in order to make sure that this is all done correctly? Balancing. So what I'm going to do now, I'm going to write it over on the side, but while I'm doing that, can I ask everyone to go and grab a whiteboard for me? What to do in order to balance equations? What do we always start with? The elements. And so in this case, I'm going to start with magnesium. Now, a trick for you, and something to think about, and the reason that I want to do this one together, is are there any compounds, polyatomic ions even, that are found on both the left and the right-hand side? Anything that like stays stuck together, if you were. Does anyone see SO4 on this side? Does it stay stuck together over on the right-hand side? So what we can do, so these polyatomic ions, okay, these ions made up of more than one element, we can actually write down the bottom here together, as long as it stays in its form. So does it stay as SO4? The answer is yes. And so I can very easily now just balance the number of SO4 to make my life a little bit easier. So this is why I wanted to show this one to you. Our final thing, what is our final element that we need to make sure is balanced here? One final thing. Great, hydrogen. So, right now, over on the left-hand side, how many magnesiums do I have on my reactant side? 1. How many magnesiums on my product side? How many sulfates, SO4, on my left-hand side? 1. How many on my right? How many hydrogens on the left?
2.
And how many on the right? Great. So is everything balanced right now? It certainly looks like it. So that is my final answer. So let's do one final example together, and we're going to jump down to number 4, because number 4 can be a little bit mean. So, ethanoic acid. So I'm going to use my same colours, ethanoic acid and calcium metal. Now, ethanoic acid, if we scroll up to page 26, we'll see that the formula for ethanoic acid, I'll use blue this time, is given to us. And we know that ethanoic acid is CH3COO. So let's write it together, please, now. So ethanoic acid, CH3COOH. plus calcium metal. What's the symbol for calcium? Ca. Fantastic. And now here's the trick. The negative part of ethanoic acid, as per page 26, is CH3COO. And what is the charge of ethanoate? What is the charge of CH3COO? Negative what? 1. Good, negative 1. What is the charge of calcium metal? Plus 2. So what am I going to need to do to make sure that this ionic formula is balanced?
Put a 2 at the front.
Put a 2 next to calcium or next to ethanoate? Great. Now here's the trick. Ethanoate doesn't play by all the rules and it is an exception. For ethanoate, we actually write it first. And this is why I want to do this one together. We write ethanoate first. Notice how in ethanoic acid, the H comes right at the end. We are now just trying to swap in that H for my calcium. But the trick here is I need 2 of them. So this is the formula for our salt. So what is the name of this salt? We always start by naming the metal. So what's the metal in this salt? Calcium. So we start with calcium. And what is the name of the negative component of this? Ethanoate. So it's calcium ethanoate. What do we also get on the side of calcium ethanoate? There's one final thing. Hydrogen gas. So H2 down below and up above hydrogen gas. Very good. So what we're going to do now is we're going to have to balance this one. And just as we did before with magnesium sulfate, we're going to group the polyatomics together. So let's write it out now. So we start with ethanoic acid. So as I'm writing this one, I'm trusting that you're writing that on your whiteboards for me, please. Plus calcium metal produces calcium ethanoate and hydrogen gas. So I'm going to give you a second to follow, but this should be right up the top of your board right now. So to start us off, here's what we need to do. Number 1, we look at any elements that aren't hydrogen and oxygen. So what elements am I looking for here? Calcium. So I'm going to write that in the middle right here. Is there anything else? Ethanoate. Great. So because ethanoate doesn't actually change anything here on either the products or the reactant side, I'm going to write shorthand here and I'm just going to write ethanoate and I'm going to be looking for that on both sides. Saves me a lot of time. I'm then going to have a look for one final thing. What's the final thing that we're looking for here? Hydrogen. Awesome. So I'm going to use some different colours now for calcium and for ethanoate and for hydrogen just to make it really clear for us. So calcium. How many calciums on either side of that reaction? Great. 1 and 1. Happy days. Our next part is how many ethanoates. So I have a look over on the left, and this is being done in yellow, but I'm going to use my purple pen now. How many do I have on the reactant side, the left-hand side? 1. And how many do I have on the product side? 2. Final thing for me, hydrogen. I'm going to use blue for hydrogen. How many hydrogens do I have on the reactant side? 1. Now, the trick here is when I say 1, I'm talking about hydrogens that aren't found in ethanoate. Okay. When I look over on the right-hand side, how many hydrogens do I have that aren't found attached to the ethanoate? Okay. So, what we're going to do now is we're going to try and balance the ethanoate first. And over on the left-hand side, what do I need to write out the front of ethanoic acid? 2. Why 2? So that I can balance everything. So let me get my pen here and I put a big 2 out the front of ethanoic acid. What that does, first of all, is it doubles how many ethanoates I have on the reactant side, meaning that I now have 2. But it also doubles the number of hydrogens that I have on the reactant side, which is also now 2. So if I was to go through and check everything off, I can see the number of calcium hasn't changed, that's fine. The number of ethanoates is now 2 on both sides. And finally, the number of hydrogen is 2 on both sides. So is everything all balanced now? Yes. Happy? Yes. So all we need to do is we go back to our original formula now, and out the front of ethanoic acid is we pop that 2. So here's what I'm going to do. I'm going to give you 10 minutes. And in the next 10 minutes, I'd like to see you working through the remainder of these problems for me.